Okay, so let me come to the third question of my cloud architecture interview series. Again, this is a much bigger discussion type of question, and this is not just a straightforward question. This is a kind of question that I ask people to understand their feel of architecture, overall architecture, concepts, and stuff like that. So, as a cloud architect, what do you consider as something that can fail in the cloud? And how can you design your applications to withstand such failures? You can consider Azure as a reference ESP if you want. You can talk about generic approaches or even service or component specific approaches. So this is more about understanding not only how to build a highly available application that comes later, but also what is your definition of failure? What are some standard approaches or generic approaches that you can take to basically recover from failure? What is the kind of thought process around this? So here are a lot of references and there's a lot of reading that you have to do in this case, and there are a lot of things you can do. But say for example, something that you need to understand, okay, is that there is you have the platform. Okay, so you can call Azure as the platform layer. You have those Azure services on top of that Azure platform, or you can consider them as part of the platform. Then you have your application and on top of that. Okay, now there can be different types of failures that are happening at each of those layers. Okay, so for example, one of the failures that normally from a cloud infrastructure perspective that we consider is, for example, the platform failure. Okay, so how we basically work on those topics is basically adding redundancy, creating highly available architectures, maybe doing multi-region deployments and stuff like that. So this is one kind of stuff that we normally care about. Okay, but then there is also the application on top of that. Okay, so say for example, I'm talking about one of the failures is that, say somebody deployed a wrong configuration in the code. Okay, now once it got deployed, so the wrong configuration that got deployed on all my VMs across all my regions. Okay, so then I will get the same issue everywhere. Okay, so even if my platform is up, my application as a whole will go down, right? So there are different approaches, obviously, but we are more focused maybe on the cloud perspective. So one of the important things that I look in the candidate when I'm asking this question is their understanding of transient failures. Okay. So, for example, in a cloud-based system, right, we are making API calls to get data, and most of the communication is happening over the internet, right? And there are many, maybe in a microservices pattern, there are many microservices or small components which are interacting with each other, dependent services. So there can be some transient failures. So this is very well explained in this document, which is a very big document, but worth reading. So how to handle transient faults. So basically, transient faults will happen. So first thing that we need to understand is that the system will fail at some time. Okay, that is for sure. So we should consider in our design that the system will fail and then act accordingly rather than considering, okay, it might not fail. So our design should embrace failure in a sense. Okay, so what we how to handle transient faults. So for example, what can be a transient fault? So there is a network outage or a service that I'm trying to call is giving me throttle response. So mostly, if you do not handle it in your code or in your approach or in your idea, what will happen is that, say your application will give an error and stop. But rather than that, there could be a good approach could be to retry. Okay, so retry is a very good approach. So rather than, it's complicated though, but rather than just taking the error and stopping the application, let me retry after some time. Maybe the network glitch will be fixed by that time. Maybe my service will be again up by that time. So retry is kind of one of the approaches that you can consider for this kind of transient faults. So as you can see, transient faults can include momentary loss of network, can include loss of connectivity to component and services, temporary unavailability of a service, or a timeout that arrives when a service is busy. Okay, something like that, anything. And this service can be a cloud service, it can be an Azure blob service, it can be an internal service, it can be an external service. I'm talking about the overall concept, not just only cloud. So why do, because obviously your data is moving across the internet. There can be n number of reasons why this kind of thing can happen. So as you can see, cloud hosting can offer okay, but mean that transient faults are more likely to occur. So there are many reasons, you can read them as standard. Now what one of, so there's a lot. So basically you just need to check if your service SDK has an inbuilt retry mechanism, then rely on that. Otherwise you can create a custom retry mechanism. That is one of the option. But you should not retry for everything. So for example, try to understand from the failure code or something, what is the failure. If the failure is because say a table is missing, okay, then there is no point in retry. If the failure is because of some network problem, maybe the data is not coming and there is some message or something, or you are getting a throttle response or something like that, then you can retry. The question is how many times will you retry, what will be your retry approach. So as you can see, determining an appropriate retry try count and interval. So it is very vital to optimize the retry count and interval to the type of use case. Okay, so it depends upon a lot of things, but for example, one of the methodologies is exponential backoff. So like you retry after 3 seconds, 12 seconds, 30 seconds, you can retry incremental intervals, regular intervals, immediate retry, you can retry just at that point, random retries. So basically, this is very important. The general guideline, you can use an exponential backoff strategy for background operations where you can wait, but immediate or regular interval retry strategies for interactive operations where you are interacting with the user. There you don't want to wait for a long time. You are doing some sort of an exponential backoff, so you're waiting like 30 seconds and then again retry and the user is waiting, right? So rather than that, something like that you can consider. uh, so there is a lot of things here. Overly aggressive retry strategies can basically cause a lot of problems, right? It can overpower your services or hamper your services. And for example, as you can see, overly aggressive retry strategies which have intervals that are too short or retries that are too frequent can have an adverse effect on the target resource or service. This may prevent the resource or service from recovering from its overloaded state. It will continue to block or refuse requests. This results in a vicious circle where more and more requests are sent to the resource or service, and consequently its ability to recover is further reduced. So basically it's like a cycle, right? You are getting an error, you are again trying, and that is again resulting in another error. So this is one of the approaches. Okay, you can read this document in detail. Okay, so you should not continue retrying. You should have some sort of a circuit break or pattern kind of a thing. So, so as you can see, the optimum approach in this scenario is an exponential backup strategy with a circuit breaking capability, because you don't want to be in a loop and continue retrying and stuff like that. So these are all very important, and you can log your failures so to understand whether they're actually transient failures or they're different kind of failures. What kind of transient failures are happening, what is the root cause. If you see one type of transient failure happening, maybe this is because a throttling is happening, then you might need to move to a higher tier of that service and stuff like that. So this is a lot of things. But at the essence, what you need to understand from some other perspective is this is in this document is that you need to understand that your system will fail, and you need to create an architecture where you embrace failure. Okay, so you should consider that okay, I can fail often. Okay, so all of your you should have automation in place. You should have appropriate automation in place so that, say for example, something fails, you can create that instance again. Okay, you should have a redundancy in place. So for example, across availability zones and stuff like that. You should consider that yes, this VM is going to fail, or my service is going to fail, or my infrastructure or my platform is going to fail. So I need to have redundancy. I need to consider my infrastructure as something that I am not very concerned about. It gets deleted, it gets created. I should not consider IPs as static. So your overall design needs to be kind of cloud native, where you agree with the concept that everything is kind of scalable, the IPs are dynamic, you are more relying on the URLs rather than the IPs, and everything is transient and everything is ephemeral and stuff like that. So here in this document, as you can see, one of the important thing is that disposable infrastructure. So you should consider that your infrastructure is disposable. You should not get tied to your infrastructure. You should always consider that my VM or my infrastructure, whatever can go down, I need to spin up something else. So the infrastructure on which your application runs should not have any identity. Okay, so you should not really care about IP address, host name, physical location of the server. Another good idea is to prefer many small distribute elements over large ones. It's like a microservices kind of an architecture. Obviously, this is better and much more scalable and basically the idea here, these are not very simple concepts. The concept is very large. Basically, if you have a multiple servers, then maybe if one of the server is down, somebody else is taking the load for some time, and your customers might not even understand the glitch. So your design should be a little bit like cloud native and stuff like that. So there is a lot of things that come in this question, and you need to understand that. At the same time, for example, some other, this is a very good article. So for example, another thing is that rather than failure, you degrade your service. Okay, so rather than giving a very bad error message or error page, if you feel that the application is unable to support for some reason, then you show a good kind of service with some kind of pause and stuff like that. Okay, basically, rather than a 500 error message or a screen like that, you give a better. So you get a you give a degraded result. Obviously, your application is not performing at its maximum level, but at least it did not fail. So your users will not feel that something has failed. So this is. Basically, so as you can see, if they can do they get the yellow and white ASP.NET screen of death? Do they see a simple browser supplied HTTP 500 error page, or do they see a page showing that the system is currently experiencing difficulty and will be back up soon? The page could maybe even display some static marketing information about the website or company to keep them occupied, and perhaps an update on what is happening with the service. Okay. So, so as you can see, in the early days of Twitter, their users were greeted on many occasions with a fail whale image, indicating that they were aware of the service problem. The service was available, but you could not tweet or read other tweets. Twitter had decided to degrade the user experience, but not fail completely. But the most important thing is you have to keep in place mechanisms to identify the failure. That is only when you can decide to degrade. So your monitoring and observability needs to be at a high level. You can use Azure monitoring, Azure instrumentation, or you can use third party like Grafana, Prometheus, New Relic, and there are many other tools that do um, this kind of a design, and it kinds of detect failures. Then the third thing is that you have to reduce the impact of failures. Okay, this is also very important, how to reduce the impact of failures. One of these is, again, as I told you, dealing with transient errors. Similarly, as I said, so do some sort of a retry. So as you can see, these retries can reduce the impact of failures that are occurring in dependent components for those times that the retries succeed, right? So deciding request buffering, so put some sort of a queue maybe between your sender and your receiver, so that in case your receiver is not working at its full capacity, then at least it does not, you do not get a throttling error, rather you are getting it's like an asynchronous processing kind of a thing where you are getting. So these are complicated topics. Obviously, this is not as simple to implement as I'm saying, but this is some kind of architecture that you can think about. Okay, and this is something as an architect you need to think about. That is the most important part of this kind of questions. Okay, capacity buffering, this is okay. Dynamic resource addressing is very simple. This is because this is what I'm talking about. You cannot rely on normal IPs because there is nothing like an IP, there is nothing like a VM. You have to consider that everything is kind of like a DNS name, so that you can quickly change those. Your application itself should change. For example, I had designed once an application which, after some retries, if it could not get a response from a storage account, it would try the read. It was the storage account was configured with RAGRS. It would automatically then try the secondary endpoint. It's automatic in my code. It was written. Okay. If this does not return the response within this kind of a time frame, then try here. So this kind of stuff you need to think about. You need to think that these items in your architecture will fail. So how, if it fails, what does your code do? Does it try somewhere else? Does it give an error message? Does it put that request in a queue and then asynchronously that request gets processed? So all of this, obviously, automation, as I told earlier also, automation is the most important thing, because if you try to recover manually, it's very difficult. And nowadays you have a lot of cloud service provider orchestrators and stuff like that. For example, Kubernetes, where a lot of this stuff is automatically taken care of by the platform, right? So if a pod goes down, another pod goes up, because your deployment mentions that the number of replicas is 2. you don't need to do anything as much like that. But yes, obviously you need some certain observability to understand whether the pod went down because of some network failure or something, or some compute failure, or because your code failed, 4xx errors and stuff like that. So these things you can do. And obviously the most important thing is to plan for failure and do checks on your failure. Even the most kind of a platform will fail. A most reliable platform can fail. That is why chaos engineering discipline has been introduced. In this question, you can talk about a little bit about chaos engineering and stuff like that, right? You can run chaos engineering activities. You can inject faults and see how your system behaves. Rather than and this will help you prepare your design rather than getting an actual error in a production system when your on-call engineer is sleeping during a work day. If you do this kind of exercises, for example, Netflix has chaos monkey, so this kind of aspects you give to the interviewer, that you are aware of all of these concepts at a conceptual level. So learn from mistakes, yes, and so you can go through this but another thing that is also very important is application level outages. So as I said, what if my code uh, deployment is wrong? Maybe I did a code, so obviously you have unit test cases, number one. But say your unit test case passes and your code got deployed, and then this code has an error which causes a problem. Now this code gets deployed to every VM, right? So all of these cases will might not help you, meaning your chaos engineering and stuff might not help you, because those failures you are injecting is obviously, but if the failure is at your code level and it has not been captured by your unit integration smoke test, then your client will obviously see that failure. So in these cases, obviously one thing, as you can see, is to split the service into test and live service. Test service, but test service are also exposed to the customer maybe. Okay, but as a test site, like a QA site, so you first deploy to QA, ask your customers or some alpha testers or beta testers, whatever, to test there or to work on those upgrades, and then you go only if it works fine for say 30 hours, 48 hours, 24 hours, then you move to this is one of the options, obviously, to run across regions. Okay, so you have basically separate setups in separate regions. That is one of the things. It is not very simple to implement maybe, but yes, self-contained services. So your same application is running in small uh, as a self-contained application in East Asia, and a self-contained application in Southeast Asia, meaning if East Asia fails, it has not nothing with Southeast Asia ideally, and you can merge changes code. You can push code first to East Asia and then to Southeast Asia. So here, for example, one of the things that is, yeah, updating sets. So even within the same mini service, rolling out a key update should preferably staggered. Okay, so this is one of them, and another thing I wanted to show you. Yes. So now it is all the more easier when you can have smaller services deployed across regions, right? So you can deploy items across. So this is not, again, all of this is not very easy to implement, okay, and not also something that you need for every, but you need to understand the concept, that at my application level also I need to do some sort of um, uh, some checks in place. Maybe I deploy to a small subset of my customers, and then I see that okay, my application is working well. There is no such critical issue that has been reported over 30 days. Then I deploy to the other application. Obviously, I have good unit test case, I have good smoke test, I have good integration tests, and stuff like that. But uh, at the same time, I also need to ensure that failures happen, and I should have run books. So, say for example, I get an issue. How do I roll back to the last stage? Is there any something I can do to degrade to so that even if I am facing an issue, my application is down, my customers can do something in some other way, maybe a parallel path of operations. So something like that. Basically, both at the application level, you need to do some stuff, and all of these are related. So the concepts are some of the concepts like uh, degrade your and throttling, and this is not just for infrastructure layer, this is also for application layer. So the idea here is that you can obviously go through all of these documents. You can read about chaos engineering, fault injection, which is a very important topic nowadays, and also asked in architectural interviews. For example, I ask people whether you are. I was also asked for a startup interview whether I am aware about chaos engineering and the basic concepts around that. The idea is basically to inject fault and see how your systems behave. Okay, in small, and Gremlin is one of the chaos engineering providers. So the idea is to understand this overall architectural concept at a high level. Okay, like how this kind of failures can happen. What are some of the stuff you can do at a high level? You need to keep in mind to address those failures and so on. Thank you. Please share your comments also. Thank you.